I think we communicate in more ways than we currently understand. But I do think that, like, to answer your first question about some of these features, so the physics that I'm interested in seems to suggest that the most interesting attribute of the physics is that time is actually fundamental. Ordering of events is fundamental. And elementary particles don't experience time. The universe can generate them in any instant in time. There's no memory necessary for the universe to make an electron. Electrons just always happen. But to make something like you or I requires building up objects that know how to build other objects that know how to build other objects. So there's this long causal chain of events leading to this conversation in order for this to actually appear in the universe.
Like a cell phone with Wi-Fi.
Yes. It won't happen on every planet, right? Because there's a particular history that has to happen for cell phones to come into existence. And the theory is called assembly theory. What it suggests is, so basically the way you construct it is easy to see for a molecule. You take a molecule, you break it up into elementary bonds. So molecules are made out of bonds. If you don't know about molecules, you can pretend you're playing with a Lego set. So let's say we have a Hogwarts Castle on the table. Let's use our imagination. And I smash it, right? And I ask you to build the object. There's a lot of ways of building that. And so we talk about this in terms of molecules. You think about all the possible ways of building up a molecule by just joining those Legos together or joining the bonds together. And then that defines the molecule's set of possible histories for the universe to build it. And that is the molecule in this theory. Gotcha. It's not, the molecule is not the material object you see, it's all the ways that it could be built.
Okay.
And so now the molecule becomes an object that exists across time. Because if you think about that Harry Potter castle, in order to actually build it, you have to have an idea that the castle could exist. So there has to be information in your mind, a goal. And then you have to be able to assemble it by putting the right parts together. And the particular ways that you do it are things that you see unfold in time. And so in molecules, we talk about the minimal path to make the molecule is significant, because if the minimal path is very long, you're never going to find that object by chance. So this is actually why I used Hogwarts Castle, because if I just said, let's have 3 red bricks, I could probably find that structure pretty easily. That's like the prebiotic soup, as we would call it, like simple molecules early Earth can make. But if I tell you, you have to make the Hogwarts Castle, the chances of you randomly stumbling on that are really hard.
Right.
So it's not random that thing emerges in the universe. It requires a certain history of information. So it required, several centuries ago for people to build castles and for us to learn about storytelling and invent novels, and for J.K. Rowling to come and write a novel about a particular little boy that was going to a magical school, and also simultaneously for Legos to be invented. So if you look at all the pathways to make that particular, it's not a coincidence that it emerged on our biosphere, because all the information was acquired over time. And what we do in this theory is we basically say, a molecule is that set of information, all the ways the universe can build it. And if it's sufficiently complex that shortest path is too long, we will only find that thing in living systems. Because living systems are the only physics that can build complex things.
Okay.
And so this sets up the space that living objects are objects that have a size and time. So my cup and I are both 3.8 billion year old objects in the universe. It took our planet 3.8 billion years to generate us. We're a little bit qualitatively different because the cup, requires a lot of information to build it, but it's not an active agent like I am, so it's not going to continue to generate the creative process on this biosphere in the same way you and I are.
But everything in this room is 3.8 billion years old.
Yes. And shares a common set of lineages. So that's what we're saying is the physics of life. And so some objects are older in time. And so this gets to the virtualization, because I think of things like virtual realities as packing more time in smaller volumes of space. So if you were just the atoms in your body and they weren't organized into you as an entity, they wouldn't have a depth in time. But you have a very large depth in time. So an analogy, because we can see object size in space pretty well. Like you can't fit a Mack truck in a garage. You can't fit certain evolved objects in small volumes of time. And so a lot of our technology now is putting more and more time in smaller volumes, I think.
Really? More and more space in small volume? You mean like in a small device?
Yes.
And having more objects in the device?
Your point, like if I'm talking to somebody on Zoom, somebody across the planet can be like right in front of me, right? So now you've compressed something that's thousands of miles distance to this short interaction communication right now.
Here.
Yeah.
In front of you. So what does that do to us as physical, spiritual beings?
I think it's a confusing time for our planet, honestly. And because there's a lot of growth happening all at once. And if you have children, you know what growing pains are. Or any of us know what growing pains are.
It's painful.
Yeah, it is painful.
Your knees hurt, your back hurts, you're like, you're awkward.
Yeah, but to your point, I think like there's a lot of historical knowledge that we have and we don't know how to parse it with our technology. And it's interesting to me about technology, like you were saying, you couldn't even have imagined it, right? But somebody did imagine it. That's why it exists.
Sure.
So in some ways, when I look around and people don't like Starlink, moving across their sky because they're like, it's blocking the stars. And I'm like, oh my God, human minds just put stars in the night sky. Like, how can you not appreciate the fact that everything in our environment is basically built by human minds? And
human minds put stars in the sky?
Well, Starlink.
Starlink. I thought you said stars in the sky.
Well, I did because they look like stars in the night. They look, have you seen it? Starlink?
No.
Oh, it's so cool. It's just like a trail of little satellites, but so it looks like like little, like a comet or something. Well, not a comet. Comets have long tails, but meteorites coming into the atmosphere or something. So it's like these little tiny twinkling stars moving in unison across the night sky.
It's cool.
If ancients saw it's like the airplanes, like people would have thought they were gods. Like God only knows what they would think it was. But it's intriguing to me that for all of human history, and actually, indeed, the entire history of our planet, we've looked at the night sky and just seen the stars that physics put out there, right? And now we're seeing things in our night sky that humans put there. And I think that can feel kind of alien in some sense because intrinsically we have a deep knowledge of our planet. This is why people feel comforted by the mountains and things, right? So it's like we come from this very ancient lineage on this planet. All of that knowledge has been acquired over billions of years, not even just millennia. If you go to your cellular level, right? It's like billions of years of knowledge in your body, and then thousands of years as a human. And so nature feels comforting in some ways because of that. And for some people, the built environment can feel very alien, but it's because I think it's because it's new, and because of this feature of being constructed by us, basically building stuff in the world around us. It's like the externalization of the human mind. AI is sort of a similar thing. It's like people feel like AI is very alien, but if you look at the progression of our technology, we built microscopes that allowed us to even know that we were surrounded by life. So like this whole table is covered with microbes. If I had brought a microscope in, we could just be inspecting, like what's growing on your table.
Microbe.
And then, we have seismometers that allow us to feel earthquakes, obviously important in California. And we built telescopes that allow us to see like the deepest, parts of the universe, right? And we have quantum devices that allow us to probe these properties that we never knew existed. And now we're building technology that works off of principles we think our own mind works on. And so
we're growing a lot right now.
Yeah, we're growing a lot.
Tell me about the quantum field. What is that for people to understand?
Oh, so quantum physics it's interesting because it's a theory that predicts features of the universe that seem quite odd for us because they're features of the universe that become apparent at really small scales. So some of the features that seem kind of weird are like these kind of uncertainty relations. So if you know the exact position of something, you can't know its exact momentum. Momentum is just kind of like a feature of its motion. So, like if I try to put you in a little box, I couldn't tell how fast you were moving, right? And that's kind of a weird feature. And then there's, like quantum entanglement, which is if you separate two particles that were interacting and you make it so that they can't communicate, they still will act like they're communicating.
Really?
Being separated. So these kind of features seem very odd when quantum mechanics was founded. And of course, a lot of people that have, originally proposed quantum physics and people that study it now say that, this is a theory no one really understands. There's not a standard interpretation of it. A big problem with quantum mechanics is we don't actually really know how to define a measurement in the sense that there's something called the wave function, which I assume is what you're talking about. So the idea is, particles have this sort of wave-particle duality, and you can describe it's kind of an abstract thing that exists in this mathematical space, which is the wave function. And when you take a measurement, you might collapse it to an exact measurement, but it might be in a superposition of states before that. The superposition, there's an example of like Schrodinger's cat. Schrodinger was a very famous quantum physicist, which is like the cat could be alive and dead in the box until you take a measurement of it. This is what quantum physics would say. Of course, quantum physics doesn't apply to large objects, it applies to small objects. But an element electron, if it could be alive and dead, it would be both properties at the same time. Gotcha. It could be over here and over here until you take a measurement, then you can say where it is. And so this property is weird because now you have to say, well, what is a measurement? And measurements are actually kind of hard to talk about from this. Everything is actually really hard when you try to construct a theory for it.
Sure.
And I think people don't appreciate how hard it is, like how to get to quantum physics and general relativity and these things is really, really, really hard. It's an incredibly creative and painful process. And coming up with new theories is emotional. And you have to like rely on this deep intuition. So quantum physics has these weird properties, and there's like the many worlds hypothesis, which is like the interpretation of quantum mechanics that all possible realities exist simultaneously. And the measurement is just, like branching the wave function. So you're just saying you're on the one where the Schrodinger's cat was dead, but there's another one where it's alive and it just split into two realities instead of being one.
Like a multiverse.
Yeah, sort of.
Different realities, gotcha.
Yeah. So,
interesting.
Yeah, so it's interesting. The theory says a lot of interesting things. There's a lot still to be solved and understood about it. And a lot of people want to take sort of insights from quantum physics and apply them to sort of general principles of reality. And I think that's a bit of a stretch because quantum physics actually doesn't explain what life is. And we haven't solved the physics of life and we don't know the physics of mind. And I think that physics might be even more interesting and even weirder than quantum physics.
The physics of mind.
Yeah.
Where is the mind?
Presumably in your head, but not really.
Right.
Depends on your concept of self, I guess. I don't know. My mind feels like it's inside my head, but I also feel like I'm not an individual sometimes.
Is the mind the same thing as consciousness and awareness?
Yeah. So, well, it depends on what kind of question you're asking and what you want to know.
I'm just curious. Yeah.
Yeah.
I'm just curious. Where does the
what
mind
do you want to
come
know
from?
about your own mind, or where? Yeah.
Is my mind in my head, or is it sensing
Everywhere.
the universe? Is it everywhere and yet here at the same time?
Yeah.
Is my consciousness in my mind? Is my soul connected to my mind? Is it in a different place?
Right.
Are they talking to each other in a different way?
Yeah.
How are they connected? Are they connected
see.
like the body, or is it surrounding the body? Is it a sphere of energy rather than inside the body?
Right.
Yeah,
I see what you mean. I don't think anyone has good answers to those questions. And if they claim they do, you should ask them a few more questions.
Sure.
Because I think the most interesting thing with these kind of things is when you start talking to different people who have thought very deeply. Like, I meet all sorts of people all the time from different walks of life and different scientific training, like some of the best thinkers in the world. And you get to these sorts of questions, and there's a lot of deep mystery there. And I think that's good. Like, we should embrace the mystery and we should embrace the unknown, because if we recognize the things we don't understand, then we have the capacity to understand them. I love this Marie Curie quote. It's like, now is the time to understand more so that we can fear less. It's not exactly, she has a much more eloquent way of saying it, but
sure.
So I don't think that we have a good answer to your question, but I do think, the sorts of ways I know people talk about it. So some people want to think, so you're asking a question about consciousness. Consciousness, the problem people are interested in there is not like your thought process, but the fact you actually experience anything. So like sitting in this room right now, we're experiencing colors, we have feelings about them, we have like a mental image inside our head. And some people find that to be a very mysterious feature of consciousness. And where does that intrinsic experience come from? And it seems very difficult to explain that particular feature based on current what are called materialist narratives. So physics is based on the sort of principles of materialism, which is that matter exists, whatever you want to define as matter. So that's a whole nother hard problem.
Sure.
Matter exists, like particles exist, atoms exist. And if you want to describe the properties of those things, it seems like there's no place for mind to actually exist in that kind of description of reality. And so some people want to take sort of a dualist perspective that mind exists in this other plane and then interacts somehow with the physics. But that actually has a lot of problems because it doesn't explain much about why those things interact, how they interact, why would it be the case that I have thoughts that do anything in the world. And so I tend to think that we really do exist. We are physical beings, but we might not understand the physics entirely yet. And I think that's much more productive because there you can then construct concrete questions about what would a physics look like if I built it based on these kind of properties I see and not the ones that maybe were developed for studying other areas of physics.
Is there anything you know for fact, for true, like about the world, about the universe? Is there actual truth that we can as human beings agree on? Or are they just theories that we agree on?
I think they're theories and they're descriptions, but I would say I think we can. It's actually one of the hardest questions is to like what would be the thing that we can agree on, or what's the ground truth?
Like universal truth.
Yeah, we don't know.
We don't know.
We don't know. I know.
Is that exhausting?
It is, but it's fun. I mean,
do you feel like you're running around in circles I don't.
No, I feel like I'm moving in a direction.
That's good.
And I think the direction is like nominally what we might call human progress. Like we move in a direction of hopefully building better lives, right?
Yes.
And building more creative things and possibilities. And I think a large part of that is trying to understand the reality we live in and coming up with concrete explanations for it. And they're not permanent. Like there won't be an ultimate explanation, but there will be a better explanation that allows us to get to the next phase.
So, from a physicist's point of view, have we figured out what the meaning of life is, or is that just for each individual to figure out?
It's both. So I would say each individual should figure out the meaning of their life. But I would say what I think, like when I think about what life is, what life does uniquely in the universe that no other kind of system can do is the creativity. And so I often will describe the physics of life as the physics of how the universe generates novelty and how it explores the space of what's possible. So there's a lot of things that could exist. Not everything gets to exist. We can imagine a lot of things that don't exist. But the unique thing that's happening on our planet that we haven't observed on any other planet yet, but hopefully we will if we find alien life, is that things that we can imagine to happen or can create new knowledge on this planet actually generate new possibilities. Like the example I gave of satellites, or your example of the TV screen.
Or airplanes.
I couldn't have imagined those, but somebody did imagine them. That's why they exist.
And it creates new possibilities. We can travel the world, or we can connect with friends around the world, or we can gain information or knowledge from a device.
Yes. And it's not all possible things, but it is a large subset of interesting things that can happen on this planet that can't happen elsewhere. And I think that's what life is doing.
How do we use your work to discover what each individual's mission is in life? Is there information we can gain from the work you're doing?
I think, I always like to think what would be the physics 300 years from now? And I always think like morality or purpose might be interesting. So I do think about the implications of it. And I guess the thing that's interesting for me is to think about every living thing that exists as a unique thing and a real causal force in the universe, and to some extent. And for me personally, I feel like when I'm aligned with my purpose, like I feel like my purpose, this is really cheesy, but I feel like my purpose is to help humanity understand what life is. Like that's why I exist. Don't ask me why I think that, I have no idea. But when I think about that question, and that as my driving goal, all sorts of things happen that are interesting. And I feel happy. It makes me happy and fulfilled. So I think, but also, because I think about the physics of life, I always have this sort of meta level of description of what Sarah's doing. So I do these, and I talk in third person when I think about it from a meta level. Yeah. So I do these like thought experiments about theoretical physics of theoretical physicists, which is, like when you build theories, what do they do to reality? When you're a physicist and you build a theory, you care about making a prediction and doing an experiment. But when you're thinking about it from this sort of meta level, you're like, what are the downstream consequences centuries hence of building this set of ideas in humanity now? And I guess it's that sort of long-term thinking and that ability of purpose, and to think that your agency actually matters in the future, that then you can you can start to do your life's best work. And it might be, like that is taking care of my kids, or that is, trying to do $1 billion initiatives to solve the origin of life so we can understand what we are and deal with existential crises that we're facing now as a civilization. And it can bridge all those things, and it looks different for different people. And I also think that's part of it, because if you think the universe is trying to maximize creativity, then we should be individuals, but we're also collectives because we're part of the same phenomena. So I think thinking about both those things also is important, to realize that other people aren't really that different than you. I'm optimistic. Obviously, I couldn't do what I do wanting to study alien life or origins of life if I thought we were the only life in the universe. But we don't have any evidence that life exists elsewhere yet. So I have to kind of maintain my optimistic and skepticism hats at the same time.
So there's no evidence of alien life anywhere?